I'm Mallikarjun. I work at Flipkart. I bring an interesting talk at the scale of Flipkart, that how we solve multi DC multi cluster setups, um, uh, which is powering a lot of use cases in Flipkart. Yeah, okay, let's get started, right? Okay, this is the agenda for the talk. Um, I'll give some basics of HBase uh, to just make you understand what it is and how it does, some basics of it. And then I'll talk about the server capabilities that can assist in setting up a multi-DC sort of a setup. And then the deployment strategies, how we deploy our clusters, and then talk about how applications make use of it. And then on the client side of it, what sort of capabilities that we have to assist clients talking to multiple clusters of HBase, multiple data centers across multiple data centers. And then a concept called intent rights, and then a concept called change data capture, how it works in multi DC setup, right? So this is what is a agenda. Okay, let's get started with the architecture of HBase, right? If you look at the screen, there are two layers in HBase. HBase has a lot of components to it compared to many other advanced databases. There's a HBase layer and HDFS layer. In HBase layer, there are two components which clients interact with. So this being a customer application, say you are maybe transactional application or search or something else, which talks to zookeepers to understand where the shard lies for a particular shard, which region server hosts the data, and then later talk to region server. Region servers will make use of the HDFS layer to store the data. So this is how it works in very basic terms. And HBase data layout, if you look at, there's a concept called namespace, which is a logical grouping of tables. And each table is divided into shards called regions. And then they're range-based shards. Say if you have a map, say 1 to 10, then 1 to 3 is one shard, one region, 3 to 6 is another shard, another region. So you can have any number of regions, you can split and merge and do whatnot, and that's the regions. And then each region, independent of which table it belongs to, hosted on a region server. Here, if you look at RS1 is the region server. Each region server is hosting some regions, some shards, right? In this case, table A1 region and table A2 region is hosted on RS1, and table B1 region. So this is spread across, and that's how the data is laid out on HBase clusters, right? On when we talk about HBase write path, how it works is, so here customer meaning the customer application, say like I said, maybe a search application or some functional use case. First, it makes a change. It inserts some data, it modifies some data. A mutation is nothing but a change that is going into the database. Once it goes, it writes at two places. First, it writes to in-memory data structure, which is having the data need not go to disk, or it can go to disk as well, but making it in memory makes it pretty fast. And then it appends to write ahead log. So what the unique specialty of this write ahead log is, this is append only file system. That means any change that, say for example, if you look at MySQL or something, so you have a B tree, for example, and then in B tree you have to identify which node to modify, where to, you have to search for it, you have to modify it, and so on. When it is persisted to disk, or when it is doing disk based operation, it is slightly, the IO is higher on the disk side, but here it is append only. That means you don't have to search for where the data is, just append the change as it is to a file system, which is append only file log, and then you write it to memory. Since memory is faster, so you improve the write efficiency. That's how HBase works. And this write ahead log is used for recoveries in case of a disaster. For example, you're writing to memory which is not persisted to disk, which is not permanent. So if the region server crashes, then the wall write ahead log is used for recovering the data. So that's how the write path is. And this in-memory structure, which is going to be flushed into disk once in a while, say if there's a memory pressure, say if it reaches a threshold, say by default I think 128 MB, it flushes to disk. And once it is flushed to disk, then your data is persistent. Then wall is no longer required, right? And walls are also having some specified size configurations, say 64 MB, 128 MB. Once it reaches, it creates a new wall. Anyway, there's no looking or anything like that. It's just append only file. This is the right path. The replication path, in replication path, like I said, there's something called as wall, which is append only, which is ordered. Whatever the input that is coming from customer, say I write row 1 at this point, and then row 2, and then I go back and modify row 1. There is order, right? So this wall, was there a question? Yeah. So this wall is going to store the data in the order in which the customer has made the changes. So this wall can be used for replication to other DC. See here, there's a dotted line in between both sides. One, this one being say for example DCA. On the right side there's a DCB. So there are two clusters. Customer is writing on DCA. He writes it, and data goes to wall, and then from wall there are some threads which read the mutation being a change, read the mutations, whatever the order that it came in, and then write to the other side of the cluster, that is other side of the DC, right? So in this case, it's coming in the order in which that was created, returned to the other DC. Now data is there on both the DCs, right? And again, there's a sync replication and async replication. Sync replication means that you're going to incur latency when a customer writes, or there's challenges with respect to that. Async is good enough for most of the use cases, and at Flipkart we use only async. We don't use sync replication, right? And one other point is when the source wall reader is reading and writing to the other DC, there is something in between goes, say filtering, and then some changes, modifications, and so on. I'll talk about it when the respective slide comes. All right. Yeah. So in terms of deployment, so I made it pretty complicated here to understand how the real world looks like. Say for example for Flipkart, how it looks like. So here, if you look at this application A1, application 1, which is deployed in data center A, which is deployed in data center B. So you have active setup. Say for example, you have 1,000 customers, 500 customers go to one side of the DC, one DC, 500 customers go to other DC. Then what happens? You want your application to be available in both the DCs. So here, one application number 1 is available on both the DC, and here application number 2, here you can see my cursor. So here application 2 is also hosted on both the DCs, right? So then in that case, your requirement comes that you want your database to be also available in both the DCs. So similarly here, application A1 talks to cluster A1 and cluster B1. So maybe there's a connection setup, not talking right away, or talking for getting some data, or whatever it is, the connection is there, right? And then also application A1 talks to cluster A11, right, which is an extension of A. I'll talk about the real world scenario in a bit, right? So here A11 is replicating to B11. A11 and B11, these two are equivalent. A1 and B1, these two are equivalent. They have the same data. A2 and B2, these two are equivalent, right? So there are 3 HBase clusters, 2 applications. One application talking to 2 HBase clusters. Another application is talking to only one HBase cluster, right? So this is made intentionally complicated so that it represents the real world, how it looks like in the real world, right? Now I'll talk about why the setup is such that you have A1 talking to both A1 and A11, right? For example, you have some application, say for example a payment application, right? Say in payment application, you are say when you're initiating the transaction, when the consumer goes through an e-commerce website, he's putting some items into cart, and then he's checking out, going into the payments page. So when he goes to the payments page, some identifier is initiated, and he doesn't go and complete it. More often than not, you go to the payment page, you come back, right? So then what happens? Your application is creating some entry, some identifier that needs to be persisted to disk, but that's not, it is not necessary that it needs to hold on forever, because the customer might not complete the payment. So then what happens, you are going to write to the local DC, that is A1 is writing to A1, A1 application is writing to A1 HBase cluster, and B1 is writing to B1 HBase cluster. They are cross replicating. You don't need consistency. You eventually consistent is okay, right? But then when customer goes to write, make the payment, the payment is confirmed and so on and so forth, then you might not, you might want a higher consistency level. Then what you will do, you will do go to the active passive setup. Say here, if you see HBase cluster A11, HBase cluster B11, this is an active passive setup. They are not cross replicating. There's active passive. They can cross replicate, but what I'm saying is, there is an active passive setup, not active active setup. So in that case, application A1 choose to write it to a single cluster. Even if you look at B1 is also talking to A11 cluster, B1 is also going to write, and then all of the data is getting replicated to B11, right? So you can have pretty much any complicated scenarios like this, with maybe geolocated whatever that can be set up in such a way. Now this is how some of the applications are deployed at Flipkart. Uh, Now this is the basics of how HBase is, what HBase is. Now we'll talk about some capability HBase gives to enable the cross DC replication sort of a setup, right? So first thing that is expected is acyclic replication. So for example, you have 3 data centers A, B, C. So here there are 2 data centers. Say I'll put a third data center A, B, C. You write in, say, data center A, and then the wall entry is read and returned to data center B, and then the same wall entry is written to data center C. Now C again can write to A, because there is cross replicating setup across all 3 clusters. That is not productive, because data is keeps on moving around, it's never ending. How do you identify that? So what HBase does is, each cluster, each HBase cluster has a unique UUID that is created at the time of the start of the cluster and exists forever, right? This UUID is appended to any data, any mutation that is persisted to wall. At the time of creation, it creates an imprint saying this is the cluster ID um, that is where this particular mutation has originated, right? And then when the source wall reader is going to read, and source wall writer which is going to write to the other DC, then the cluster ID of the destination cluster is also appended to the UUIDs. So in this case, each mutation will have the array of the cluster IDs, which in all DCs, or sorry, which in all clusters this particular mutation has seen. So this way, it's able to identify that, okay, I'm writing to, say, cluster A back, but I see that cluster A is present in this list, so I don't have to write it back. So I can stop this particular chain of replicating events. No, snapshots are there for a different reason, but wall is how you can replicate, because of some functionalities like the ordering is maintained and so on and so forth, and also you can process it in the way that is coming and so on. No, it's actual data. That's what. Each change, it's not related to how your data is structured, but each change. For example, you're having, say, right now, row 1 with data Y, right? And then you made some change, row 1 to data X, right? That change is the entry that's getting mutated in the wall, or it is persisted to disk. No, it's not a bit memory. It's written to memory. That's the structure in which you can query and read. The wall is append only, right? So it's you don't have to random read and then you get it. So obviously the efficiency will be better if in case of a random read, random write versus a sequential write. So that difference is what is going to improve if you look at, say, millions of QPS. That's so So filtering is required. So filtering, when you're reading it and then you're writing it, the filtering could be for various reasons. One being, should I write to the destination cluster? Is there a say, for example, if I go back here, there's no replication from B11 to A11, right? So I can say, okay, there's no peer for this, so I'm not going to replicate back. That's a one filter. Another filter is, this cluster has already seen this mutation. I don't need to send it again. So that could be. So there are various filterings that you can even introduce whatever you custom logic that you want, so that the filtering can be used, right? Yeah. Okay. Acyclic replication is one capability that helps in setting up multi-DC setups. And another capability is conflict resolution, right? Conflict resolution is a bit complicated to handle if you want truly consistent sort of a setup. Here we are talking about eventually consistent. So we are okay with what the basic set of capabilities that HBase gives. So what happens in HBase is, HBase has a concept called multi-versions, right? You make a change, it's there. Say for example, you create a row X with the data A. If you look at here, my cursor, row X data A, that is there in the database. Now you make a change to row X with data Y, right? So it's not that it's modifying the X row with from A to B, rather it is adding one more version. So there are at any point in time there are multiple versions that are going to be stored. There's a background process which kicks in now and then to clean up the data whichever is not required, right? If you by default only one version is always answered back. If you ask the query, it's always going to give you the latest response, but there might be more than one version that can exist at any point in time. There's no guarantee that you will have more than version, but they can exist. And background job is to clean up whatever the versions that are no longer needed. That concept is there in HBase. That's called multi-versioning and so on. So here, if you look at the example, at start, someone has written to row X version A at T0. That's already there. Now at T1, on the, so if you look at, there is a left side and right side. Left side cluster in in data center A is called A1. On right side it's called B1. Both are active. Both are modifying the same data, right? For row X on the data center A, change is made to become B. On data center B, it is made to change C at different points in time, T1 and T2, right? So now there is a possibility of a conflict because you are writing the data at the same time on both sides, not at the same time, some change in time on very near time, T1 and T2 being very small difference, right? Now if you look at what happened in the next phase, on data center A, it has become AB, B being the latest. If you ask a query, it will give you B as a response. On data center B, you see C is the answer that you're going to get. So this is the temporary state. And then they're cross-replicating with each other. So you see that the mutation has gone on across the DC. And then eventually you see that the row X has version A at time 0, version B at time T1, version C at time T2, and then on the row, on the cluster B also, you see the same order, right? So at this time, if you query with T1, T0, T2, whatever the latest timestamp is the one that is considered as the latest version, latest data that is there. It's going to give the same. So that's where eventually it is consistent. Both are going to get the same data, right? The trick part is, what if the time offset, the difference is too huge between data centers, right? For example, in data center 1, it's 10:30 now. On data center 2, it's 10:55 now. There's 20 minutes difference. So in that case, if you make this change, then obviously the expected results won't come, because here you're ordering by timestamp. The data generated at DC1 is imprinted with the timestamp of DC1. At data center D2, they imprinted with another timestamp. So it is essential for the clusters to be NTP synced so that the deviation between these two data centers is not huge. In that case, they are almost similar, a few seconds difference. So in that case, you are bound to get the results that you are expected. Right. So this is how conflict resolution is handled in HBase. So these two capabilities helps us in setting up the deployment setup that I just showed in whatever the topology that you require for applications. So we were able to solve on the HBase server side of things. Now let's look at the client side of things. If someone has any questions, they can ask. Otherwise, it depends on how you want it. For example, you have 3 clusters in 2 DCs, then you can replicate with each other and then all 3 have the same data. You say that no, only 2 is sufficient, then you set up 2 clusters and replicate with each other. So however you want it, you can set it up and then this one. Yeah. So yeah, correct. So that's active passive setup. So A1 is also talking to A11, B1 is also talking to A11, A11 is down, but A1 and B11 both are having connections to B11 as well. Correct? So that's what you can set it up if you want. You don't have to set up. For example, if A11 is down, then what you will do is all your application A1 and B1 will talk to B11 because B11 has the data. And then when you bring up the A11, then you set up the replication back, and both A1 and B1 will talk to B11, continue to write, and B11 will replicate to A1. Or you do that, you replicate cross replicate between these two, and then you start writing to one DB, and when the DB is down, then you go to the other and write that, because replication is already there, so it'll continue in that way. So you can do it in both ways. Yeah, sure. Okay. That not does, his question is there read after write consistency? Yes, there won't be if you're talking to the other DC. If you're talking to the same DC, then you will get back the same response. That's what these DCs are cross replicating with async replication. When async replication is there, you can't read after write. If you're writing to a DC, read from that DC. If you're reading to other DC, generally what happens is applications are set up in such a way that they have a fixed set of say for example rows, right? So say row 1 to 100 is going to talk to only this DC, row 200 to 200 is going to talk to this DC. And then in case of a disaster stuck, I'll talk about how it is handled. In case of a disaster stuck, then you have to switch over all of these. That's when read after write will become a problem during the interim, maybe for some duration. And otherwise you continue to talk to A1 for specific set of rows and A2 for specific set of rows, like that. Yeah, that is on the server side of setup. Now we'll talk about what we have done on the client side. Client side is where HBase client is very primitive. It gives very basic sort of a needs. You will have to do a lot of things to get the multi-cluster handling needs to be done. So first of all, HBase client gives you basic configuration, which will talk only to one cluster. You need to change the configuration to ensure that there's multiple DC identification, there's multiple cluster identification, all of those will be part of it. I'm not going to go ahead. I'm just putting as that something that we have added. Okay, some basics about what we have done on the client side before we go into the client wrapper specifically. What is a replica set? A replica set is nothing but, so in previous talk also there's a talk about replica set where there's a primary, there are two replicas. What replica set means is all of the clusters having the same data, that is a single replica set. Here if you look at, I have done color coding so that it becomes easy. A1 dash, A1 and B1. These three are cross replicating with each other. Eventually, all three will have the same data. Wherever you write it, it doesn't matter. Data will go to the other. So this is a single replica set. Here on A2 and B2, that's a single replica set. So this is what a replica set means. This application can talk to any of these nodes within the cluster to get the data. Based on the consistency guarantees, you might want to talk to where you write the data or maybe the asynchrony replicated. And one other thing that you notice here, two data centers, but three clusters are there for A1. Uh, in single data center also, you can have multiple clusters based on your needs, topology, whatever the needs that you have, you still might require it to have. Say, for example, on hot store, you might keep it for 30 days. On cold store, you might keep it for 6 months or 1 year, right? So here in this case, A1 being a hot store, A1 and B1 being a hot store, A dash A1 dash could be a cold store or warm store, where if application is able to do a deterministically identify what is a when was this row modified or what was the timestamp and so on, then he'll be able to directly talk to A1 dash if it is older than a month, or he can talk to A1 and then know that okay, this data doesn't exist. Now I'll go talk to the cold store or warm store and things like that. You can have any sort of a topology requirement is possible. So this is what is a replica set mean. Each cluster is independent. Each cluster is not sharing anything with other. So, right. So that's just a basic logic saying if it's not there, I go read it here. There's no metadata as such. Again, you can have application side identification saying, okay, if row starts with X, then I should go to this Y cluster and things like that. There's nothing on the HBase side for that. It's all on the application side logic on how they want to split the maybe customers or anything, orders or anything like that. There's no, they might have some metadata somewhere. We don't have any solutions around that. Yeah. So the next thing is consistency level. On the client side, we have introduced consistency level for adding more capabilities, which I'll talk about later. So we have introduced 4 consistency level: primary mandatory, primary preferred, local mandatory, local preferred. Primary mandatory means that always I have to write or read to primary only. What is the primary? In a replica set, say you have 2 nodes, 2 clusters. One cluster is responsible for customers which is identified from 1 to 100, and the cluster on the data center B is responsible for 100 to 200. Now you have a clear cut segregation saying 1 to 100 is the cluster A, data center A, 100 to 200 is the data center B. So when you have clear cut identification, then the primary for 1 to 100 is A side of the cluster, secondary is on the B side of the cluster. So that if you have that sort of identification, we'll talk about this a little bit later, then primary mandatory will talk to always to, in this case, application A1 will always talk to cluster A1. Primary preferred means that if A1 goes down, then you talk to B1, because primary is only preferred, primary choice, not the mandated, right? Local also very similar. If local is unavailable, if it is mandatory, then you are not going to write to the other DC. Maybe you have a latency requirement saying it should be less than 10 milliseconds or something like that. Then you always write or read to latency. Your availability will take a hit when in case the cluster goes down. And then you write to the, if it is preferred, then you go to the other DC for as a fallback. These are the consistency levels that we have introduced. Now we'll talk about routing. This is slightly, there's a lot of information here. I'll go into each of the mentioned numbering here. Yeah, you can carefully look at my screen and then see what I'm talking about. So first, say let's talk about an insert. Let's talk about a modification, right? So again, if you look at the color coding here, the gray part is client application, your application that which is writing to talking to DB. The blue part, whatever the shade it is, blue part is the client library. That is the library which we have written on top of HBase client, the client wrapper library, right? And then green part is the HBase cluster, which the client library will talk to once the decision is made whom to talk to, right? Number 1 says that make a change, right? Once the invocation is made to the client library, there is identification of a site. What is a site? Site is nothing but a cluster, right? Say for example, in this case, here if you look at A1 and A1 dash, right? Site A1 and site A1 dash is there on data center A. Site B1 is on data center B. Site is nothing but a zone, data center cross cluster. That's what site means. So here 1 is the cluster, A is the data center. That's what a site means. Okay. Get sites. So each call, so you don't know which application is talking to you, right? As in which data center it is. What you will have to do is when a call comes, you have to identify whom to talk to. There are 3 clusters set up. Which cluster to talk to, right? You have to identify the site. So when identification of the site, there is a interface that is part of the client wrapper called hot router, and the client application will have to implement it to whatever the custom logic that they want, right? If you look at hot router, which get sites will go and get the replica sets from, here is the simple code logic, right? It is a little small. I don't know if I can do, yeah, right? So if you look at here, what happens is custom router, which is implementing the hot router. If you look at here, there are 2 replica sets. Primary group A, where is it? Master slave replica set group A, master slave replica set group B. So in group A, there are 2 sites or 2 clusters, with primary being site A in Chennai DC, secondary being site A in Hyderabad DC. Okay, so group A means that Chennai is the primary, Hyderabad is the secondary. So you have 2 clusters, one in Chennai, one. Yeah, this is better. Yeah, I can zoom in further because I'll not be able to show you everything, right? Yeah, so there are 2 replica sets. Group A means Chennai is the primary, Hyderabad is the secondary. Group B means Hyderabad is the primary and Chennai is the secondary. That's what these 2 replica sets say. And when if you look at the previous slide, sorry. So in the previous slide, what get sites means, it will invoke the hot router to get what and all sites I'll have to talk to for this particular call, for this particular row. So there are 3 different implementations here. I have put a end of block to complete that. So first says that if whatever may be the scenario, always talk to replica set group A. Always talk to, because there's no logic here. It just returns replica set A. It says talk to this. Talk to this means that primary is Chennai, site A, secondary is Hyderabad, site B. Okay. There's a second implementation. In second implementation, what it says is if route key starts with A, some logic, whatever the logic is. If it starts with A, then talk to replica set A. Replica set A means that Chennai is the primary and Hyderabad is the secondary. If the route key starts with B, then it's the opposite. Talk to replica set B. Okay, and then there's a third implementation. Sorry. Yeah, there's a third implementation. What third implementation is a little more tricky. Say, for example, you're doing a payment application. If payment is done or in fail state, that is, it has reached the end of the life, then talk to cluster A. Okay, this is for the A one that I spoke about earlier. If payment is done, that is, it has reached the terminal state, then you talk to the cluster in Chennai. Okay, if it is in init or pending state, then you talk to B. Or it could be that if the state is in init or pending, you talk to the local DC. Whatever may be the scenario, whatever may be the logic, you can implement it here, and then you can route each and every call that goes to HBase based on various other scenarios. Say in this case, you have a configuration which is dynamic configuration. You make the change configuration, it can get reflected here. In that case, if a DC is down, then you make the configuration change, it will immediately get reflected here, appropriately route the traffic. You don't have to do anything. You just change the configuration saying DC1 is down, and automatically both applications on DC1 and DC2, DCA and DC2B, both are going to talk to the same data center. Say DC B HBase cluster, because DC A HBase cluster is down. right? So you can do as whatever that it's required. Okay, so step 2 is to get the replica set for every call, and then once you get this replica set, then you check what is the consistency levels that is required. So if it says that I want only primary mandatory, then in the replica set there are two clusters, one is primary and one is secondary. You discard the secondary because it's primary mandatory. So in that case you only go and talk to the primary. If it says that it's primary preferred, then you start with primary. If it fails, you go. So and then you talk appropriately, you make a decision in the client wrapper, and then you talk to the appropriate HBase cluster, right? Yeah. So what happens is HBase, unlike MySQL, is not there's no single node. It keeps on changing, right? Earlier, if you look at the slide, what happens is first application will talk to the zookeeper and says that where are all the regions spread out, okay? And then say region 1 is on region server 1, region 2 is on region server 2. Then appropriately your call is directed to that particular region server. And then if region server 1 goes down, then these regions are spread out again, right? So then the region 1 can go to region server 5. So there's no fixed set of a cluster. So you cannot have some sort of a ELB or a proxy because it keeps changing. It's very dynamic because this is a slightly advanced database compared to probably a more simpler database. So that is the reason why we can't use something like that. Mhm. Yeah, right. See, again, right, this is also you can have a proxy in between and then you make a decision. This is another layer which was integrated with the client. So the decision of so one other thing is each application is different, where you might have slightly, like for example I showed in this code that you can have various strategies in which you want to deploy your topology and then make a decision. So if it is in the client library, then they'll be able to or intercept into it and then make the change accordingly. That's one of the reasons why it is part of this application rather than something outside. That is one other debate that has happened, and some of the stateful stacks have decided to go in that direction. But in this case, that is not the case. Yeah, so far good. Routing, yeah. Yeah, it is open source. There's a link at the end of it. No, we have written it. HBase is very basic client library. We have written a wraparound of it. These are the capabilities which I'm talking. Correct. Right. So that's the reason why I'm talking here, and then we have open sourced it. I've written a blog about it. So it's to promote people to use it instead of building something their own. It's called under Flipkart incubator, what do you call, org. There is HBase client itself. Yeah. And I have link here. Okay. So another concept is intent, right? So what is the intent? Intent means that you are, say for example, if in a state machine also you do, I'm doing this, I did this, I'm doing this is the intent. That means you're going to do something. There you are going to have the intent stored somewhere saying, okay, in a payments context, I'll say that I'm going to initiate a transaction. This is the transaction ID. After that, it goes to PGs, it goes to something, something, and it takes a lot of time. Meanwhile, if your HBase cluster is down, then you don't have a track of it, right? That's where intent becomes important in a multi DC setup, right? So here, if you look at, if you follow what is written here, application A1, say for example, in a payment scenario, it wants to create a new payment for a specific customer. Then it writes intent to an intent store in the other DC. Okay, it says that I am going to initiate a transaction with this identifier. Okay, and then it goes, first it does intent, right? And then it goes and writes to the cluster on the local DC. Local DC, the other DC, both are cross replicated. And then next instant, after some time, A1 dies, and that particular transaction was not transferred to the B1 because there is some network connectivity or whatever it is. Now you have lost the transaction altogether, right? In when money matters, you can't lose it because customer will say, oh, where is my money? I made a payment, but I don't see anything is there, right? Because order is not created or whatever it is. Now on the B side, you detected that, or even on the A side, you detected that there's a failure, there's a cluster, HBase cluster down, then you can have your logic coming in, and then your logic says that go figure out from the intent store if there is any transaction that was initiated, see how you can recover it or reconcile it from payment gateways or the other outside beyond your channels. So go figure it out and how you can reconcile it. You can uh, this client library also has intent capabilities, and HBase being one of the integrated intent store as well. You can have more as well. So this intent is used for scenarios where you require your data loss completely is not acceptable. You need some information where you can reconcile from other systems. Maybe you're not the source of truth and things like that. So there's capabilities like that also, which is used by some systems, even including payments. Right. So that is, these are some of the capabilities that we introduced in client side to be able to handle the multi-DC setup. Yeah. You can write, that's what you can use B1 also as the intent store, but intent is not your primary data, right? If you make that intent, see which store, intent store A1 or cluster B doesn't, is not the point. The capability that there is a concept of intent which is getting written outside of your primary call is the point here. Application, instead of each application doing okay, I'll do a intent write somewhere and then I do it here, instead you abstract it out and give a simple interface saying you make a call, we will do the intent writes within the wrapper. So on the application side the interaction is bare minimum. This is the capability of client wrapper, not the application. No, it's serial. Your goal is to keep, and also it's not, if you in a payment journey there could be 5 calls you make, on the only the first call you make the intent and rest of the calls you don't make the intent. It is serial because intent is absolute necessary for you, right? That is on the client side of things. So there's a third part of it, that is change data capture. So what is change data capture is also it's called side effect processor. What it is you have a change, you have some mutation in your database, then the change is important for you to maybe store this data in a secondary database for you. Maybe you want some analytical purposes, this is a key value store which is good, not good for analytical purpose. You store it in something like Mongo and you do some sort of analytical queries. That's one scenario. Another thing is you have a distributed transaction, you have payments, card checkout, order management system, all these three have a distributed transaction. When something happens, then you talk to each other saying, okay, my payment status has changed from A to B, then now you go change whatever you want. So if you want to do a distributed transaction also, this change data capture becomes important. That's where one of the reason why it's called side effect processor also, right? So here in the same logic of replication between clusters, there's the write ahead log, you replicate the entries, and then there's a CDC change data capture replication point that we have implemented. This is also open source, and then we filter and produce based on various filtering, which we'll talk about in the next slide. And then you write it to a distributed queue like Kafka or Pulsar or something like that. Once you write it to distributed queue, then data is taken out and used for secondary. Maybe there's a stream processing engine which reads from a distributed queue and writes it into a secondary DB or puts it into some other queue for completing a distributed transaction. This is the concept called change data capture. So what we have done is we have introduced capabilities in filtering capabilities so that you write it in various ways. Let's look at 3 ways that we have introduced, right? Earlier I said each cluster is having a unique UID. Each mutation is imprinted with that UID, where this was originated, where this has gone, where this has gone in the serial fashion, right? So if you look at first one, replicate to CDC in region local queue, that is whichever data center the data was originated, you write it to the local queue. Don't replicate, don't write the replicated queue. So in that case, what you will do is you will put a filter saying only replicate if the cluster ID is this. Okay, that's one scenario. Second scenario is all of the data should be returned to one replicated queue. Sorry, one distributed queue. So in that case, in one DC you put a configuration saying replicate none. In other DC you say doesn't matter which DC to this data was originated, you write everything to the distributed queue, right? And third scenario is you have a list of clusters which you want to distribute in some specific data center, and in some data centers you don't want anything. So you have complex set of use cases, or probably you, for example, you have three DCs, one DC is having lesser capacity, you don't want to set up a distributed queue. In two other DCs you set it up. So whatever that change setup or topology that exists, you will be able to configure your CDC in such a way that write to this distributed queue for whichever cluster that sort of that sort of capabilities also are added to our change data capture. And this replication endpoint is a extension of HBase cluster replication endpoint. We have implemented and we have written a library and we have open sourced it as well, right? That is about change data capture. So key takeaways are, there are three sides of the story. One, the server side, the capabilities HBase gives. We have understood it and then we have made use of it. That is one side of the story. The second side of is client library. We have introduced several concepts to assist all of our customers within Flipkart. Our customers, I am part of a database team and we have customers internal applications which make use of it. To cater to their needs, we have built client library, which I just talked about. And then we have to have the change data captured. Again, our customer come with various requirements saying all my data should go to distributed queue or split and so on and so forth. To handle those requirements also, we have captured. So these three stories put together is what Flipkart handles multi-DC setups, with HBase being a database, one of the databases. Yeah. No, we have more than 200 use cases within Flipkart for using these capabilities, as in like using HBase as a store. And this ranges from search to transactional path like cart checkout, order management system, post order, fulfillments. So diverse set of use cases are there. Yeah, so we have enough what do you call observability metrics to identify and then showcase that there's a problem we have to recover and all. Generally, in a BAU scenario, that nothing happens, everything is good. Rare scenario, these things happen and someone will interfere and then sort it out and so on. Again, this is built for a diverse set of use cases. Each will have their own constraint, their own restrictions, and their own set of problems. So they can configure, choose to go in certain direction. They can choose not to go in certain direction. We'll leave it for them to decide what is best for them. So we will provide only the technology, and they'll decide how to go about it. Yeah. Any other questions? Correct. Yeah, so this is giving to the application developer to decide how they want to decide each call, where should it land, right? If there's a default implementation also, in default implementation also there's certain ways of doing it. They can go ahead with it, or they have some custom requirement, they can go and make use of it to handle it. Because a lot of customers come and ask us, we want in this particular way, how to do it? Then we'll say use customer router and then do this whatever that you want to do. And typically we encourage dynamic configuration so that any change they'll be able to dynamically load it without application deployment and so on. Okay, so these are the references. There's a blog post on it. There's a client wrapper that we have open sourced it, and I put HBase documentation in case someone is. You can Google all of these things, but I put it here. Yeah. Thank you very much.